Okay, lecture 14. Do something nice for you guys that showed up today. And what I knew was Gannon. Nobody else told me anything.
Yeah, I don't know who exactly went. I just know that some.
Yeah, Gannon's the only one to talk to me about that. So probably just for bonus, take out a sheet of paper. Showing up right before break. Have an in-class assignment / quiz. So for those that are here, and Ms. Hines, we can get you on. I'll put you on a separate piece of paper. What color is a black and white Holstein?
Black and white.
Okay, I've handed back the exams. Pass those in. So the exams, for those of you who have been in my classes before, your grade is on the back page. So if you flip it over, that's the grade I have in the Excel spreadsheet where I keep all the grades. If I get ambitious, I will learn how to do that in bright space over break. But for the moment, it's on the back there. So you're gonna go through on the bottom right-hand corner of each page is the total points on that page. If there are any math errors, let me know. I'll fix them for free. If you don't agree with the way I graded something, or you took a different approach to the question than I thought we might or should, you can turn your exam back in, put a cover page on that says I don't agree with page whatever. This question, I think my grade should be higher. Or I had a different approach. I interpreted the question differently than what's there. So if there's any discrepancy, turn those exams back in for regrading. I reserve the right to regrade the entire exam. Related to that. So couple of quick points related to the exam. So first page. Everybody gave me their pulse, so we did there. A few people didn't put their names at the top of the page. That's so I keep track of things in case things come apart or we get things out of order. And also, if I don't look at your name while I'm grading, since that's the last page I get to, I don't know your hand. I don't learn your handwriting if I work from the back to the front. So it's just a way to put an identifier at the top of each page. Page one, pretty straightforward. There were lots of options. So with the front and back of the cow, you could have interswapped any of those. I think I caught most of those, but if I didn't, hand them in for a regrade. So for number relating or situated to the head, P, B, or N, situated near closer to the feet, H, E, or O, caudal, O, H, or E, retaining to the head, N, P, or B. So interchanging those. I tried to give people credit, but that gets a little difficult when you're doing all those things in your head. Sometimes you don't catch them all. So if there's a difference there, let me know. Showing me whatever you needed to. On this page, it seems that a lot of you should have stuck with your first impressions. So, standard answers here. Proportions, hydrogen ions, stuff in solution, water is there, explode, shrivel, hydrocarbons, hydrogen and carbons, something in addition to the hydrocarbon that gives a character or function to that molecule, usually polar, dehydration, hydrolysis, carbohydrate, protein, lipid. There's a range of answers for defining characteristics, traits, or features. Something related to on page 6, build, burn, or store for later. There were 7 classes of protein. I asked for 4. We're looking amino acid, nucleic acid, so phosphate, sugar, nitrogenous base, the nitrogenous base variable, phosphorus, phosphate and sugar groups are constant, R group variable, NCC is constant throughout all protein or amino acids. Page 7, solute actively moved, water follows passively. The body manages solute, water follows hopefully in equilibrium. Tertiary, final shape, something about the R group interacting with water. Transcribe, translate, copied, codons, code for individual amino acids, that R group or the tRNA group that pulls in the right amino acid. Page 8, a range of answers, depending on what we're looking for. There are multiple options here. Depending on which one you picked, you could pick either one. If you defended it adequately, you got full credit. You can argue either one. Triglycerides store energy, phospholipid membrane for phospholipids, unsaturated versus saturated, range of answers. Increased proportion decreases the melting point or freezing point. Decreased proportion of unsaturated increases the melting or freezing point. Something like that. Matching things up, nucleus, endoplasmic reticulum. I gave, I think, half credit for ribosome there. Sort of part of it, but not all of it. So pretty straightforward. I took the definitions off the slides and put them in the test. So a range of answers on page 10 for why we keep that co-parallel. There's several reasons. I was looking for a good story for full credit. Parts of the hoof, parts of the corium, parts of the bone. There's lots of different things you could say about those. I asked for 2. Lameness, the weight is thrown to the outside claws. Their answer that came up a lot is most of the weight's on the back feet. No, it's not. It's the way she walks and throws that weight to the outside. So there's less weight on the back feet, but because the way she walks, she puts more on that outside claw. Suspension. What happens to suspension of the bone and hoof as feet overgrow, not trimmed frequently enough? Lots of things can happen. looking for 2 of them. Same thing with the corium swells, is compressed or damaged for any number of reasons. What's going to happen? Mechanical failure, infectious, lameness, nutritional lameness, range of answers there. Purposes of bones, if you go through all the lectures and collect everything together, some semblance of these answers. There's probably a few more that I didn't get, but support, structure, protection, yellow fat, blood cell manufacture, movement, all those are purposes of bones. You could probably store calcium in there. I think that many of you came up with that one. Axial skeleton, some discussion of the skull to the tail, that center line of the body, appendicular is limbs. How do bones grow? They differentiate from an osteoprogenitor to an osteoblast, osteoclast, osteocyte. Then there's mitosis, hyperplasia. They secrete protein and secrete minerals. Low blood calcium leads to increased parathyroid. The parathyroid goes to the osteocyte and tells the osteocyte to draw calcium from the bones. Calcitonin works in the opposite direction. Periparturient hypocalcemia, low blood calcium around the time of calving. These are the letters I thought were best for the answers for the bones. There were some I went through. If you didn't match mine, is what you put there a reasonable substitute given the way the arrows are drawn and the locations and things like that. So some of you got credit for some things I did differently. If you don't agree with what I did, you can lodge a formal protest. So, scapula, humerus, radius, ulna, carpals, metacarpals. A lot of questions around this part of the body. So I was pretty lenient going through here. Everything else is pretty straightforward. Femur, patella, tibia, talus, tuber, tarsals, metatarsals, sections of the axial skeleton, frontal bone, mandible, thoracic, associated with the ribs. This is the ribs. I think on the next one we use ribs on the other side. Sacral vertebrae, skull, cervical, lumbar, caudal. I think I gave ribs for this one just because of the way the arrow was pointed. But I wanted it to be sternum. So if you have any questions or considerations, let me know. So as part of assignment 7, you're going to take a look at this exam and see what you might do differently next time. That probably is meant for a lot of people who aren't here, but what you like about what you did, taking a test is about mental preparation as well as knowledge. Did you leave your best effort on that test? And I know we've got a few students who panic when they get to a test. You need to address that. And there are people here on campus that can help you with that. Because there's got to be nothing more frustrating than walking into a room, knowing all the answers, sitting down, losing all those answers, and then coming back. And then walking out and it's, oh, that was the answer. Got to be nothing. I've never had that problem, but we do have somebody here on campus that specializes in this. If you want to have a consult with them, the sooner you do it, the better off you are. So we'll try to post that up on Brightspace. So there's a person over in the counseling center that deals with test anxiety. She's a sufferer, and she's come into a number of our classes over the years. If you haven't seen her yet, she's also given a number of presentations at the student success seminars. If you want customized solutions, schedule an hour with her. So did we study right? Did we do what we needed to? Did you change answers? Thinking about test taking strategies. I know I should never change an answer, no matter what. I always, when I change, I lose more points than I gain. So even if some of them I know are wrong, my first impression is always best in test taking. So taking a look at that, checking that out for yourself, learning about yourself, how do we take this test well? So did you achieve your goals? Did you get where you wanted to? So any questions on this, the information or the test I gave back? Any concerns you want to address here? So if we think about it for a moment, costs about 20,000 to go here. Does everybody feel that's a fair statement? If we do the math, that works out to about $50 dollars per class. For a 50-minute class, it works out to $1 a minute. Somebody's paying for you to be here, whether it's the US government, whether it's your parents, whether you are, somebody's paying $1 a minute for you to be here. So we try our best to give you as much. So doing well in this class, as we talked about, we go from lecture to assignment to exam. Does everybody see that flow now? So things are a little different each year, depending on where I emphasize and where I focus. Those assignments are meant to show you where the focus is for this year. So one thing we have to say is learning is hard. There's nothing easy about learning something new. Sometimes you have to fight for it. I'm here to help you learn, and I will work as hard as you do. So if you have questions, concerns, come talk to me. We can find a way. So this is part of my teaching education. Students need to understand that learning is hard work. There's nothing easy about acquiring a new body of knowledge. Faculty need to understand that the information appears easy to the instructor is already often very difficult for the novice in the field to learn. As faculty, our job is to teach new information in a way that our students come to understand and remember that material. So if you're not getting it, I need to find another way to teach it. If there's something I'm doing that's not clicking, let me know. I can teach anybody anything, but I have to find my way in. Some people learn, everybody learns a little differently. If I can find that way for you, we can get that material and you can have that knowledge for yourself. So you may or may not be happy with your grades so far. So since I don't do it up on Brightspace, I do provide this for the moment anyway to get a feel for where you are. So what do I need to do? I need to share. So we've taken your syllabus and put it into your a spreadsheet that helps you play with where you are. So assignments are 30% of your grade. Both the ones sort of you did today, the quick ones here and there are pulse, a question, those all count as assignments. There'll be about 30 to 40 assignments before we're all said and done. And probably about 15 written assignments as you move through. So if you take the time, show up to class, turn them all in, there's no reason you won't get 100% of those. That's 30% of your grade. We're doing a project after break. I'll finalize that over break. Nobody should get less than a 9 on those. Show up to class, be present, ask questions, help where you can, attend labs, work with your fellow classmates. There's nobody, at least so far in this class, that won't get 10 in that. So just dealing with those things, you got 50% of your grade. Don't even have to take the tests. You're close to passing. So let's say I didn't do as well as I wanted to on that first exam. 50. I don't have to do anything else with exams. I can get a D in the class or close to it. Let's say I put just keep doing the same thing for the rest of the semester. Don't like Mooney's exams. I don't like what's going. I can't get the hang of them. You got a C in the class. So 50 is not the end of the world in this class. I say, okay, I got a 50. Maybe want to do a little better next time. I'm at a B. 75 is not unreasonable in this class. Maybe do a little bit better, figure things out, take the time to address where I need to be in the class. If I went crazy, I can still get an A in the class with a 50 on the first exam. So that grade estimator is up on Brightspace. Is this helpful for looking at things? There's no need to panic in this class. Do the work, put in the time, you'll do just fine. Ask questions, participate. So, questions from the class. So, do beef cattle distribute their weight like dairy cattle do? Do the lameness rules apply? Or is it different because they put their weight on differently? Certainly looking at a dairy cow and a beef cow, you're going to have two different structures. So I know the grad students that were in the beef program, those Holsteins are just too damn thin. So it's like, well, they have a different purpose. They're not there to make steaks. They're there to make milk. And they do what they do to do that. I assume going through the cows, beef cows, at least the ones I've dealt with, sort of walk the same way. But they're not going to have quite as much weight in the back. They're smaller generally to begin with. And they don't have that udder back there. They don't have a huge pregnancy most of the time. And they're terminal. They're not going to be around for multiple lactations. So they've got the same hoof, same material, but they're not going to probably put as much stress on that material. So the odds of breaking down are greatly decreased, especially if they're only around till they're 15 months old. And then they're steaks. So different set of circumstances, but I would say that there's a little less stress on those feet, especially if they're out in pasture or feedlots. They're not on concrete. So the mechanical breakdown is less likely to apply with those beef cows. Does calcium have anything to do with the electrical sink coming from the drain to the target, the brain, I guess that's supposed to be, to the target muscle group? Generally, no. We're looking at sodium, potassium are responsible for the signals. Once we get inside the cell, the catalyst is calcium. So we'll talk about that in probably 3 or 4 weeks, how nerve cells work. So is everybody comfortable with the contractions? Not sure we can do this with only 6 people. So I was counting on at least 10 here. I knew 2 people weren't going to be here. So we'll save that, I guess, for after break. Would you like a hands-on approach to learning all that? We can do it after break. So that brings us back to cardiac cycle. So did everybody here get a chance to look at the YouTube thing online, or didn't I forward that to you? If I posted it or not. So you were in class, Matt was in class, it's snow day. So we'll go through this a little slow then, because I'm guessing most of you haven't seen that. No, I got it up on YouTube. I don't know who I gave it to.
Is that the Lincoln Teams?
I don't, might have been. So there is certainly the videos in Teams. I don't know if I put it up on YouTube yet. So we're looking at our blood system. So how many people have had this before? Oh, not really. So, okay. So general convention on here is that the red is oxygenated blood, blue is not. So that helps us figure out what parts are which when we're looking at the diagram. There's also, I had a calendar a couple years ago. It was called the F in tests, F in exams. Quote unquote, actual answers given by students related to certain exams. So please label the relevant sections. Red side is where love comes from. Blue side is where hate comes from. That's not where we want to be. So, supposedly actual answers, they're just too perfect, I think, a lot of times to go through there. So saved a couple of those. So we start out with chamber of the heart. This diagram starts over here in the right ventricle. Does anybody know how we know this is the right ventricle? There are two clues in the diagram. One is deoxygenated blood. Deoxygenated blood comes from the body. The first stop is the right side of the heart. Also in the diagram, this wall here is a little thinner than this wall over here. That means it's the right side of the heart. Generally, when we look at diagrams of the heart, you're looking at someone's chest. So it's opposite of whatever you are. So right side, left side. So they're starting in the right ventricle. Ventricle contracts, goes through the semilunar valves, go out into the two arteries that feed the lungs. You have a right and left one. There's a capillary bed in there. We have the dropping off carbon dioxide, picking up oxygen. Come back to pulmonary veins. So pulmonary vein, pulmonary vein. We go to the left atrium, number 4. Left atrium goes through, the blood goes through the AV valves to the left ventricle, out the semilunar valves to the aorta. And the aorta, it's going to split into a superior and inferior sections. Superior is going to take care of the head and the front leg. Capillaries of the upper body. This inferior is going to take care of the lower body. They're going to drop off their oxygen. They're going to drop off their nutrients. And then we work our way back, work up to the inferior vena cava and then superior vena cava. They feed separately into the right atrium, and the cycle starts all over again. So we'll have to work on that as we go through. When we're looking at heart flow, one of the things I want you to do is be able to, and it's part of your homework, is to trace the path of a red blood cell. So some rules to remember: arteries leave the heart. I got excited. I see a stack here and it's like, hey, they're not supposed to be here. Yeah, so Arteries leave the heart, veins return to the heart as a general rule. There's only a couple exceptions for that, and we'll discuss them when we get to the gut and metabolism, the portal vein, and then we have a portal vein in the head between the hypothalamus and the posterior pituitary. As a rule, generally, our atrium, they become ventricles. I only put that in there because people switch those in past years. Right side of the heart feeds the lungs, which is called the pulmonary circuit or lung circuit. Left side of the heart feeds the body or systemic circuit. Arteries move with pressure. So the heart generates pressure. There's a high pressure at the heart. Everything moves from a high to a low. Blood perfuses the arteries down to the capillary beds. As we go across those capillary beds, we lose pressure. So we have a little bit of pressure to get back to the heart, but the veins rely heavily on valves to keep things moving forward. So if you have a series of one-way valves, when we're moving, we squeeze those veins. Blood can only go one way back toward the heart. Eventually, everything circulates back through. So if you're going to remember, there's lots of ways to remember. This came from a student in past years. I know none of you have ever seen this show, but something from see if we can get some sound. So lots of ways to remember the sequence. Why isn't it giving me sound?
The heart, to the valve, to the right ventricle, pulmonary artery and lungs. Once inside the lungs, it dumps carbon dioxide, picks up its oxygen supply, and it's back to the heart, through the pulmonary vein, through the atrium and left ventricle. The aorta comes with the blood leaves the heart and it's handled through the rest of the body. The arteries, arterioles, and capillaries do bring the oxygenated blood to the cells. Tissues in the cells trade off wasted CO2, which is carried through the venules and the veins. It provides a vena cava to the atrium and the lungs, and we're back to where we started in the heart. And it's back to the heart, through the pulmonary vein, to the atrium and left ventricle.
Okay, so back to there. There are lots of ways to learn that sequence going through. So you have a song to play with. There's a number of different things that I've used in the past. So for learning the parts and sequence, since it's a circle or circuit, I tend to use a circular piece of paper that goes through. So we start with right atrium, right ventricle, pulmonary artery, beds of the lungs, pulmonary veins, left atrium, left ventricle, aorta, capillary beds, vena cava, right atrium. We work our way around. So you can start anywhere, get things done. The colors on here are, is the blood, the red is the blood oxygenated or not? So yes or no. So you can pass that around. I'll open it up, take the staples out after class if you want to take pictures of it. So learning our path, the parts of the cardiovascular system, you could add all the valves there as well. That would be a very good answer if you could tell me what valves are in what spot as you move through. So we're looking to get the blood cell path down and all the parts therein. So figuring those two things out, we have that previous lecture that we move forward on that snow day as per agreement. So the other thing we got to figure out for the cardiovascular section is the heart function. How does a heart work? How does it all move together? So, best way to remember this is start with electrical. The electrical leads to contractions. So we just like with the muscle cells, heart's a muscle, something electronic happens that leads to a muscle contraction. We have that nerve signal coming down, starts our contraction of our muscle. We have signals in the heart that lead to muscle contractions. Once those contractions happen, it leads to a series of pressure changes, and those pressure changes become events. So if you can remember the electrical system or electrical sequence, you should be able to figure out everything from there. So what we need to remember is blood flows from a high to a low pressure. So that whole circuit, it's going down a cascade, getting lower and lower pressure until we get back to the heart when it starts to elevate it again. We go to the left side of the heart, big jump in pressure. That's going to push blood all the way through the system. We're going to have check valves just in case we get some lower pressures that may not be forcing things in the right direction. So cardiac contractions function in a coordinated manner to move blood through the body. We're looking at cardiac output. There are two things we have to get down. One is the milliliters per contraction, and with training, this volume will go up. And then the number of contractions per minute. So if we take those two so milliliters per beat, or whatever volume you want to have, gallons if you're a whale, beats per minute. You cross out your beats, you're left with milliliters per minute, cardiac output. How much volume is moved out by the heart per minute? So to increase cardiac output, we can either increase the stroke volume or the beats per minute. Usually with training, we learn to open up that heart a little bit more and get more per contraction. That's why those resting athletes have such a low heartbeat. Their volume is so high, they don't have to contract as much. So how is cardiac output regulated? We have a pacemaker in the heart that does most of the work. And that is called the sinoatrial node, or we'll call it in this class the SA node. I'll show you why it gets that name in a minute. And then within day, within minute, the nervous system will influence your pulse rate. How many here, when we did your pulse in class versus when you did it at the beginning of the exam, had a dramatic difference between the two? So there were some of you where it jumped really high. You're under somatic stress. My brain needs to get into the, what, 5F mode? What is it? Fight, flight, faint, freeze. I never remember the other one.
Forget.
Maybe. We'll talk about that. Basically, your heart, your brain, your nervous system is saying, you know, we don't need a brain to live right now. We need legs and a heart. So we increase the cardiac output. So the nervous system will act as a modifier on that SA node. Has anybody worked in a slaughterhouse? I used to process birds for the gourmet food trade. I was usually in charge of the plucker. So I got the headless birds, brought them over, we dunked them in the water, put them in the plucker, they float out. Every once in a while, collecting those birds at the other end of the process, you pick one up, it's got no head, but it's still got a beating heart. Because the heart is independent. And that's great because you need that for heart transplants. Be okay, Matt.
This is good. I'm not gonna be able to study for this stuff.
It'd be fun. So it got to the point where at that particular place, there were a lot of people that worked lots of different jobs. Wednesday was processing day where we collected all the birds and got them into plastic bags to deliver all over the place for gourmet restaurants. One of the person that helped in the processing room, as we called it, her sister did pastries for the gourmet food trade, and she'd bring all the rejects to the crew that was working in there. And if you didn't do it while you had blood on your hands, you didn't get any. So it's amazing what you start eating while you got with one hand when you got in the other. So we're talking about the electrical components, muscle contract or heart contractions. We need to think about two nodes. One is the sinoatrial node, also called the pacemaker, also called the SA node, and I'll probably use SA node the most just because it's shorter. This SA node sits on the right atrium. It's a specialized set of cardiac muscle that contains a pumping rhythm for the heart by setting the rate at which the heart contracts. All electrical signals in the heart start with the SA node. And then you have a flow, a relatively slow flow compared to some other nerve impulses, but you have the heart being bathed in electrical signals. All starts at the SA node sitting up on the right atrium. The SAV valve, the atrioventricular node, is going to sit in the intersection between all four chambers of the heart. So you've got two AV nodes above it, two atrium above it, two ventricles below it. So it's going to sit there kind of in the middle. The AV node does whatever the SA node tells it to. Anybody here do work on brakes? You got a master cylinder and a slave cylinder. Usually a master cylinder is right behind the dashboard. That goes out to all brakes, and there's a slave cylinder at the brakes. You step on the pedal, that activates your master, and then the slave does whatever it tells it. We had a clutch once on an S10. Took like the guy replacing my clutch, and he says, I never fixed one of these before. Trying to figure out how to reinfuse that line. Took him a day and a half to figure that out. So SA node sets the pace, AV just follows. Does whatever it's told. So SA node is going to contract the atrium. The AV node is going to lead to a series of signals that will contract the ventricles. So if we look at it in this diagram here, different parts of our EKG, ACG, or ECG, EKG. So C is for cardiac. Why is it sometimes called an EKG? Germans. Cardiac begins with a K, like my grandfather. Carl with a K, not to C. So came over the boat from Germany. So EKG, ECG, same thing. So different parts of the electrical signal are associated with different parts of the cardiac cycle. So we start with the SA node fires. That starts a series of signals that are going to bathe the top half of the heart, the atria. Once they are there, it contracts those atria. So you've got both those there. As that signal spreads across, as atria contract. We'll explain what happens then. You get to the AV node here in the middle. That's going to send a signal to the bottom of the heart. So it kind of jumps. And then we contract from the bottom up, forcing those ventricles to empty into the arteries. So why doesn't the electrical signal just keep going down? Why does it got to go to the center? Okay, that's where the node is. Node goes there. Why does it just keep going straight down? Got to pump back this way. If we keep going this way, we contract from the top down. We're going to blow out the bottom of the heart. So there's a set of preferentiate fibers that jump to the bottom and force that signal back up. So specialized muscle fibers that conduct that signal, and you get contraction as the signal jumps from one cardiac muscle cell to the next. So SA node, AV node. Those are electrical things there. So sequence of how a heart contracts. There are two phases that we deal with. Systole and diastole. Has anybody heard these words before? Where have you heard?
I don't, but I just heard those words, but
Okay.
not anything about
If you get blood pressure, you've got systolic over diastolic. What is the pressure when the heart is contracting versus what is the pressure when the heart is relaxing? So systole, we have atrial contraction first. What node is in charge of this? SA node is in charge of this. Then the AV node fires and is responsible for the second half, the ventricular contraction, that leads to a series of valves moving and opening and closing. Once we have those two contractions, we need the heart to relax. And that allows the heart to refill with blood to get ready for the next pump. If we don't have that relaxation, the heart doesn't pump blood. Everybody watch the medical shows. They're in VVIP, right?
it.
My God, no, paddles, all that stuff, right? So what happens with VFib is you're constantly on this side. You're not allowing blood to get back in the heart. The heart's continually contracted and it's not pumping blood anymore. So we need both the contraction and the relaxation to get things done. So I don't know how a hummingbird at 200 beats per minute gets that done, but they do it somehow. We've got a stylized cycle here that's 0.8 of a second. Half is in the contraction phase, half is in the relaxing phase. 0.8 of a second works out to 72 beats per minute. So this is a diagram here. If you understand this, you understand heart function. You have this one. You should have a big one of it. Or this one. Either one, they're pretty much the same. Let's start with this one. So we've got that same kind of pattern that we saw in the other one. We've changed a little bit how long the systole phase is for the atrium. We've gone from 1/10 of a second to 2/10 of a second. So we're stealing a little bit from the ventricular phase, contraction phase. But again, 8/10 of a second going across the bottom here. Time, we're counting in blocks of 1/8 or 1/10 of a second. So we have first the ECG down here, electrocardiogram. We first get the AV SA node firing. That's going to contract our atria. Then we get the AV node firing, sending the signal to the bottom of the heart. They contract, everything repolarizes, and we have no electrical activity till the next heartbeat. So with contraction, what happens to atrial pressure? This is our pressure here. It's going to go up a little bit. Not very strong. The purpose of the atria is to fill the ventricles. So as long as the atria are higher than the ventricles, which way is blood going to move? High to a low. As long as it's higher in the atria, it's going to move to the ventricles. So squeezing, contracting, we're filling up those ventricles. Once those atria are done contracting, they trigger that AV node, and that starts our ventricular contraction. So that red line going up, we've got our pressure curve associated with that ventricular pressure. Squeezing, squeezing, squeezing. At the same time, it's pumping blood out. So at some point, there's going to be no blood in that ventricle, and the pressure is going to start to fall. As the heart relaxes, the ventricle drops back down. Once its pressure is below the atria, it's going to start to fill up again. The valves are going to open up again. And then you got the rest phase where the blood's coming back, filling up both the atrium and the ventricle, trying to fill that heart for the next contraction phase. So we have the arterial pressure. It's falling down, falling down. As soon as the ventricles beat again, there's going to be a point where the ventricle pressure is greater than the arterial pressure. And during that time, the ventricle empties out. The valve opens up. If the pressure on one side of the valve is greater than on the other side, and the valve will allow it, it will flow through. It's a one-way valve out of the heart. So as long as the ventricle is greater, blood moves out. As soon as you get to the end of that contraction, the pressure drops, that valve closes. That leads to the arteries. It takes things away from the heart. Then in that resting phase, blood is moving out of those arteries. As blood leaves, the pressure continues to drop until we get that next ventricular contraction to bring that back up. So everybody following the pressure event so far, any questions? So from a pressure perspective, which goes or does more work. Left side, right side, the ventricles do more than the atrium. So small pressure increase, big pressure increase associated, ventricles do most of the work. So they take that low pressure once they're full, bring it way back up to push the blood through the body. So anybody want to guess what PCG is? Nope. Pressure's up here. Nope. I assume it's phonetic for heart sound. So these are the sounds the heart makes. What do we talk about for heart sounds? What do we listen to? Does anybody ever have a stethoscope on their own heart or somebody else's? Traditionally, we say lub dub. So this is lub, this is dub. So lub dub, going around. So the first heart sound is lub. The second is dub. So where do you think those sounds come from? They come from the contractions? Not specifically. Okay, it is part of the beat. The heart sounds come from valves closing. So you got that sound here associated with the AV valves closing. They're the semilunar valves closing. So we can think of it this way, right? If I've got my valve, right? When's it going to make a sound? When it opens or closes? Close, it's going to make a sound. Open, it's not. So anytime the valves close, we get a sound. And there are other heart sounds that we hope we don't deal with, but if those valves don't close as tightly as they might, we get other hissing sounds and things like that that we really don't want. So let's take a look at the valves based on pressure and sounds that are created. So we have the atrial valve or atrium contracting. At some point that stops. So what happens to the pressure in the atrium when that stops? Falls down, right? We stop the end of the contraction, it relaxes, it drops. So now the pressure inside the ventricles is higher than the atria. The pressure is higher in the atria there. We have a check valve, our AV valves. You can't go backwards, so it closes. As long as the pressure in the atria is greater than the ventricle, the valves remain open. Once the pressure in the ventricles is greater, that check valve shuts and we get our first heart sound. So as soon as the ventricles start to contract, they're going to increase in pressure. And the first thing that happens is the AV valve shut. That check valve going back. So the connection between the atrium and the ventricle is stopped. Anybody following? So as the pressure builds, we're pushing against a closed system to start with. The semilunar valves do not open until when? The pressure in the ventricles is greater than the artery. Again, high to a low. They're check valve. They don't flow backwards, at least we hope they don't. But once the pressure in the ventricles is higher, the semilunar valves open and the ventricles empty out. Those semilunar valves stay open until the pressure in the ventricles drops below what's in the artery. Then we get our second heart sound. Semilunar valves close. As the pressure falls in the ventricles, as everything's relaxing, at some point we get to the point where the pressure in the ventricles is less than the atria. Once that happens, that check valve can open up again. Then we have the heart filling both the atria and ventricle in this diagram here passively. The semilunar valve is only open from here to here. The AV valves are open from here all the way back to here. So two valves are never open at the same time. That's why we get that love dub as well. They're moving independently. They're check valves, preventing backwards flow. So as long as in the direction of flow, as long as the high is greater than the other side, they will remain open. Once it switches, they close. So that artery will remain closed. Those valves, semilunar valves, remain closed until that next beat, and we get that up there. So everybody following this particular diagram. There's a lot of information in there. So same sort of thing here, different diagram. We add a little bit of volume. So this is from the 8th edition of the Farm Animal Anatomy and Physiology book. So phonocardiogram, heart sounds. You got your electrocardiogram through. We've got ventricular volume, how much is in the ventricles. So we talk about the resting, everything's passively filling. The atria, when they contract, atrial systole, top those ventricles off. And then as the ventricles contract, the volume goes down, and then we passively fill again. So you've got the same pressure curves as you had before, the same crossing patterns, where things go above and things go below. So everybody following that. Everybody hanging in there. We didn't take a break. We're going to let you out early. So how do we think about this going back to our original? Remember that electrical leads to contraction, leads to pressure changes, leads to events. How do we put this all together or write the narrative on that? Those two different illustrations of the same thing. So let's summarize that, what we've learned. Okay, so if we break the bulletin board down into sections. We've got Electrical on the top row. We got contractions. Fractions. Section for pressure and events. And then we have phase. We have the AV valves. And the semi-lunar valves. Is our bottom section. So what are our electrical events? So 2 nodes firing. That's pretty much it. Where's it all start? Maybe, but we said that the heart's on its own. It can set its own beat. Now, sometimes we'll add, like with my aunt, we add an electrical one that will make sure the SA node is doing what it's supposed to. So let's start with the SA node. Fires. What does that lead to? What muscle contraction? Atrial contraction. When the atrium contracts, what happens? We have an increase in atrial pressure. And then what does that atrial pressure do? Increase in atrial pressure leads to what?
Pushes blood in
To where?
toward the center, toward the bottom, and then
Toward the ventricles. That moves blood to ventricles. You can think about it, everybody knows how what Japanese subway system works. They hire retired sumo wrestlers to push people onto the trains to get the train as full as it can be. Because if they don't fill it maximum, there's a big backlog of people trying to get places. So they push everything in, get them in the trains, fill that train up so when it leaves the station, it's full. I don't know about the sumo wrestling part, but I know the rest is. Would make sense they like sumo, they hire sumo wrestlers, but I know there are people there that push to fill the trains. Okay, SA node fires. It's gonna bathe the top of the heart, the atria, in electrical signal to cause it to contract. What's the next step for our electrical system? AV node fires. What happens with the AV node? Signal to the bottom of the heart. That leads to what?
pushes it into the center.
It does, but how does that happen?
Muscle contractions.
What's contracting? Ventricles. Contract from the bottom up. Okay, as the ventricles contract, what happens? Eventually, where do we start? We start with a pressure increase, increased pressure in ventricles. As soon as we increase that pressure, what happens? Look at your diagram. What happens? As soon as that starts to contract, the AV valves close. And that is our what? First heart sound, love. Then what happens? Got both sets of valves are now closed. Pressure is building. Until what? That's when the valves open. So SL valves, semilunar valves, open. What does that sound like? Nothing. Take our hands apart, there is no sound. What happens when the valve opens? Pressure release in the form of what? Blood leaves the ventricles. As blood leaves the ventricles, what happens next? Pressure drops. Leads to SL valves closing, which is what? Duh. Then the heart relaxes. As the heart relaxes, what happens? Will eventually, what has to happen first before it fills? Nope. Pressure drops. AV valves open. Then we get to Tim's heart fills passively. And it remains relaxed till what? So is everybody following these sequences? Start to make a little bit more sense when we think about electrical, contraction, pressure. Yes, no? Okay, so we got SA notifiers, AV notifiers. What is that?
Dolly?
Systole. So that's from here to here. Then we get what? Diastole. Heart is in a relaxed phase. If we look at our AV valves, when are they open? Pressure drops, so they open right here. They continue to stay open till when? So when does the AV valves close? Describe that, what would it be? When the ventricles are contracting. When they're not, the AV valve is open. When is the SL semilunar valves open? Sort of the opposite, but we got the AV valve closing, then the semilunar valve opens and it shuts again before the AV valve opens again. Any questions? So we can do the same thing again. Got all the things in sequence going around. Guess it should be going this way. And again, I did something in red for systole and diastole, S and D. So any questions? Is that reasonably clear or? So next week, when you come back, hopefully we'll have everybody back. You'll get to demonstrate that to me out in the hallway that you know that this is what this is. So we'll do a hands-on activity when you come back. If anybody, here's my diagram of what's on the board. If anybody wants to take a picture of that, that is up here. You have the two circular things. If you want to take pictures of those, they are up here as well. The time is yours. Have a good break.